Hello everyone, myself Saurabh. So today we are going to discuss about an important name reaction in organic chemistry. So the reaction is the Favorskii rearrangement. So this reaction is very important from uh, exam point of view or other competitive exam also, because we can see this type of question always comes in this uh, exam like exam gate NEET, etc. So what happened in Favorskii rearrangement is that uh, an esters or acid is formed. The reaction is basically happen in case of alpha halogenated system. So the alpha halogenated system react with a base like alkoxide, hydroxide or amines to form these esters or acids. So this is a general overview of the Favorskii rearrangement. So cycloalkane with alpha halo group give ring contracted products, while rain acid is the product when hydroxides or amines are used as bases. So you can see this uh, compound which abstract a proton from HO negative to form esters, to form carboxylic acid, and also uh, this abstract A this can react with this base, means FMO negative methoxide ion to form an esters. Okay, so let us discuss about the mechanism of Favorskii rearrangement. So first of all, a base abstract the proton from that side where halogen is not present. Okay, so the base abstract a proton from here or here. So the side will be preferred where halogen is not present. Okay, and next, cyclopropane ring will form during the reaction, and cyclopropane ring will be break in the final step of the reaction, and esters will be formed or acid will be formed. Okay, so let us see. So we can consider this compound where base present is NaOET, that is sodium ethoxide. So ethoxide ion can extract a hydrogen here to form a negative charge. So the negative charge can attack the that side where halogen is present, and that is why halogen is depart, and a cyclopropane ring will be formed. And again OAT negative can attack here, and double bond is shifted here to so that O acquire negative charge and OAT is attached. At the final step the ring will be break. So it is important in which side the ring will be break. So the ring will be break in that side, means it can be break in that side where it can form a stabilized structure. So if we break this ring from here, then a unstable analysis form. Why it is unstable? Because here methyl group is present, so which can donate excess electron density here. That is why the ion gets stabilized, unstabilized. If this anion is formed in that side, it does not require any negatives and any extra negative charge. Why it is unstable? Another point is that if we all know that if a negative charge is already present, if extra electron density is it extra electron density, if this negative charge get, then it become unstabilized more, because here already electron density is present. If in this case there is no electron donating group, and the negative charge get stabilized, so that ethanol, in the presence of ethanol, the negative charge can acquire S plus, and it get this stabilized structure. Let us consider an example. Okay, so this compound you can clearly see there are two halogen group. The most important thing about Favorskii rearrangement that the halogen group must be present in order to happen this type of reaction. Means this the basic criteria of Favorskii rearrangement that the system must be alpha halogenated ketone. Uh, so we can see here two halogen group is present. The question arises how we remove these two halogen group. We can see this in this case that one halogen group is left or departed from here. So the another question arises how two halogen group should be removed. We should remove two halogen group. Okay, so the base present is NaOET. First of all, as usually happen, the negative charge is developed in from that side where halogen is not present, so that OET can abstract a hydrogen here, so that negative charge is developed. The negative charge can attack here, so that bromide group is left, and that is why a cyclopropane ring is formed. In the second step, the OMe group can attack here to form O negative OMe. Means there are the two group is attached here, so that because double bond is shifted here to become O negative, and in the next step O negative can donate its electron density here to form a double to get stabilized. Okay, so that here negative charge can negative charge is shifted here, and this ring is break. If we break this ring, we cannot break this ring, because if we it does not necessary to break this ring, because here no halogen group is present. In order to remove this halogen group, we must break this ring from here, means in this side. Okay, so that the bromine group is removed. So this ring is break, and that is why their negative charge is developed. The negative charge is shifted here, so that bromine group is left out at the end and a star is formed. So what we basically learn about Favorskii rearrangement. So the basic criteria of Favorskii rearrangement that the system must be alpha halogenated ketone. Alpha halogenated system. It should be alpha halo ketone. In presence of a base, it can the reaction is proceed, and at the end an star is formed. Okay, so the another thing is that first thing should be the system should be alpha halogenated ketone. The second thing is that the base abstract a proton from that side where halogen is not present. And the third important thing is that the cyclopropane ring will be formed during the reaction. Cyclopropane is, as you can clearly see here, cyclopropane ring is formed during the reaction. Cyclopropane ring must form. And the fourth important point is that cyclopropane ring will break in this reaction in order to form an ester. So here cyclopropane ring is break from that side to stabilize the structure where stable structure is formed. So the cyclopropane ring is formed in that side where a stable structure is formed. Here an unstable anion is formed. I already mentioned the reason why it is unstable, and this is stable, so that it can abstract a proton from ethanol which is present in the system to form an star. So I discussed this a tricky question where two halogen group is attached. So I hope you like this video. Thank you.